All right, so today we're going to start by talking a bit more about going from the graph back to an equation. So we're going to do one more example of that. And then to start talking about how we're going to go from a description back to an equation, do some examples of that. And that'll wrap up section 3.1 for us today. Sound good? That's good because you didn't have a choice. Okay. So, if I want to get an equation out of this graph, usually the first thing I'm going to look for is the midline. So just looking with my eyeballs, it appears that the midline is here at y equals 1. So that tells me that my k value is 1. And I guess let's organize our work here a little bit. So I'll do my work for my answer in terms of sine over here. And I'll do my work for my answer in terms of cosine over here. And the nice thing about the k value is it's going to be the same for both of them. Everybody so far so good? Next thing I like to do is look for the amplitude. So remember, the amplitude is the distance from an extreme point, a max or a min, back to the midline. So for example, that distance there is our amplitude. So our midpoint is at 1, that maximum's at 4, so my amplitude then would have to be 3. Now notice here that I'm not writing down that a is equal to 3, I'm writing down that the absolute value of a is equal to 3. We'll sort out here in a moment whether a is going to be negative or positive. Just for the record, there are correct answers in which a is both negative and positive, so it's just about making sure that everything matches up in the right way. But there is certainly a correct answer where a is positive and a correct answer where a is negative. Next thing I'm going to do is find the period. So the way I like to find the period is I look from like max to max or min to min, just whatever's convenient. I use those because it's visually easy to pick out where the maxes and mins are. All right, so this is one period here. And I'm starting at negative 225 pi and going to negative 1.25 pi. So I had to have covered pi units to get there. Are we cool with that? Okay, and I know that one period is 2 pi times the absolute value c. So I can solve and find that the absolute value c is going to just be 1/2. And I had told you last time that when I do these, I always just assume the c is positive. Again, there are correct answers in which c could be negative, although in my experience, it never is easier to find one of those answers. So I just always choose to make c positive because there is a correct answer when c is positive. So I'm just going to find one of those. So far, so good? Okay. Typically, the most difficult part of this process is finding the h value and identifying the correct sign for our a. That's what we're going to do as our last step. So what I'm going to do is I'm going to pick a point from the parent function. Typically, I like to pick either a midline point or a max or a min because those are easy to find. And my preference on these is always to pick my point so that the x-coordinate is 0. So for sine, that point is 0, 0. That is a midline point. And as we mentioned, there's two different kinds of midline points. There's a midline point that goes minimum, midline point maximum. And there's midline points to go maximum, midline point, minimum. So we need to make sure we're indicating which one of those two types this one is from the parent function. This is the one that goes midline, or min, midline, max. And now I'm going to look at my transform function and find a midline point from that. So if I go to my transform function, I have any of these midline points would be acceptable to use. It doesn't really matter. Let's say for the sake of argument, I chose this one just because the numbers are really easy to work with. So that's the point 0, 1. If I look at the surroundings of 0, 1, we go minimum, midline point, maximum. So I'm going to record that also. And now I have all the information I need to determine my sign for A and the value for H. Since I have the same type of midline point in my parent function and transformation, that tells me that my A is positive. And because the x-coordinate for my parent function is 0, that tells me the x-coordinate for my transform function is H. So in this case, my final answer would be y equals 3 times sine of 1 over 1/2. You could write that as 2 times x minus 0. You could write that as x plus 1. Since they're notes, I'm not going to simplify that down, but certainly you could if you'd like to. Just as a little aside, let's talk about why the x-coordinate from the parent or from the transform function is giving us the h. So remember that to go from a yes.
How do you get c again? Sorry, I just totally missed it.
I know that the period is equal to 2 pi times the absolute value of c. So I just solved that equation for c.
Thank you.
Yeah, no problem. Okay. So we know that to go from a point in my parent function to get a point in my transform function, we use this map, right? Cx plus h, ay plus k. So what this says is that, for example, c times our x-coordinate from the parent function plus h should equal my x-coordinate from the transformed function. So in our case, where that x-coordinate from the parent function is 0, we have just that h is equal to the x-coordinate from the transform function. If that was not the case, we'd have to solve for h algebraically, but there's really no solving to do if that x-coordinate is 0. Let's do cosine version now. So cosine, the point whose x-coordinate is 0 is 0, 1. That's a maximum. So for my transform function, I'm going to find, or I need to pick another extreme point. So either a max or a min would be okay. So like any of these guys would be okay to use. For the sake of argument, I'm going to use this one, which is at negative 0.25 pi and negative 2. Negative 0.25 or 0.25 is 1/4, so. And that was a minimum. Since these are not the same kind of extreme point, one is a max, the other is a min, that tells me that the a needs to be negative. But still, since my x-coordinate in the parent function is 0, my h needs to be the x-coordinate from the transformed function, and I have everything I need. We all okay there? And because these are all, or for each of these kind of things, you have the graph, so you have access to any points you want. They're all kind of basically the same, right? You can do them all the same way that we just described here. Any questions about this before we start talking about going from a description back to an equation? Arya?
So for the sine graph, basically, if you choose the point 0, 0, a is always in it. If you choose like midline graph, always in the a.
No. If I had chosen, say, instead, had I picked like this midline point, where it goes max, midline, min, so to the left of it is a maximum, to the right of it's a minimum, my a would have to be negative in that case, because it's the opposite kind of midline point. Does that make sense?
Yeah.
So that's how I'm going to determine whether I'm going to be using a positive or negative a, is I have to see, is it the same kind of midline point, or are they opposite kinds of midline points? Just like with the cosine, are they the same type of extreme point, both maxes and both mins, or are they opposite? One a max, the other a min.
So we should always use.
Those are the easiest to use. You don't have to use those ones, but if you do, the h just becomes the x-coordinate, and there's no like little algebra to deal with. So it just makes it a little bit easier, because you can kind of do it on site. There's really not any, like I'm writing stuff down for your notes so you can see what I'm doing, but like down here when I did this, there's no calculation that I had to do to get h or a, right? I just wrote down what I saw basically and what I'm comparing, but there's nothing, there's no real work to do by doing it that way. You know what I mean? Does that satisfy you? Okay. So up next, we're going to go do something that can be a little bit more challenging. So here we're going to go from a description to an equation. So let's say that our graph has amplitude of 6, period of 10. My pen stopped working. There it goes. And we pass through the point, I don't know, -5, 8 or something. So I'm going to do these kind of the same, or format these the same way. I'm going to write a cosine answer and a sine answer. Unless you're asked for both of them, you don't need to give both of them, but I'm going to just do it both ways, and we can talk about like which way was easier, which way was harder, or whatever, okay? Or what the difference is. So the amplitude, that just tells me that the absolute value of a has to be 6, right? Again, I don't know if the 6 is going to be positive or negative yet. It might be positive for one answer, negative for another. There's correct answers either way. The period of 10 is going to allow me to find the value for c. And I'm going to assume, again, in these cases, that c is going to be positive. And then somehow I should be able to get the value for h, for k, and the sign for a, all from that point, negative 5, 8. Everybody's okay with that? So, negative 5, 8, that point. Do we know anything about that point? Does it tell us that that point needs to be a minimum or a maximum or a midline point or something else? No. So we can choose where to put it. We can put it wherever we want on our function. Is everybody okay with that? So if I'm going to do a sine function, where do you think I want to put negative 5, 8? What's the point from the parent function that I'd prefer to use if I'm using sine? 0, 0. What type of point was that? That was the midline point. So what I would do is for my transformed function, I would pick negative 5, 8 to be the exact same kind of midline point. So that tells me that since they're the same kind of midline point, that a needs to be positive, because the x-coordinate of the parent function is 0, the h value has to be the same as the x-coordinate for my transformed function. And because the y-coordinate from the parent function is 0, the k value has to be the same as the y-coordinate for my transformed function. So I get all of that stuff really for free without having to do any real work to get it. That's not too bad, right? Suppose we had done or wanted to do a cosine graph. Again, unless it specifies, you can choose whichever one you want. If I'm using a cosine graph, what point from my parent function would I want to use? 0, 1. And that was a maximum. So I would want negative 5, 8 also to be a maximum. So that tells me the a also has to be positive because we're going max to max. Because the x-coordinate of the parent function is 0, the x-coordinate from our transformed function needs to be the h. But now notice that the y-coordinate for the parent function isn't 0. So I have to solve this equation to find k. A times the y from the parent function plus k equals the y from the transformed function. And that's all. So which one was easier? The sine was a little bit easier, right? You didn't have that extra solving step for k. K you got pretty much for free. So if it's me, on one of these where I'm not specified whether I'm using or the point needs to be a maximum or minimum, I would use sine because it's just a little bit easier. Is that okay? Let's do another example. So let's say that we have basically the same problem, but this time we're told that negative 5/8 needs to be a minimum. So the A and the C are still the same as before. Everybody's okay with that? Okay. Here, would it be easier to find or to use sine or cosine here? What do you think? Well, cosine is going to be the easier one to use. Let's do that one first. The reason I know it's going to be the easier one to use is because the point that I know is an extreme point. If I was given a midline point there, sine would be easier. Or if it wasn't specified what it was, sine is easier. But if I'm told it is an extreme point, probably want to use cosine. Not that you can't use sine, it just, it's a little bit more to do. So let's do the cosine version first. So my preferred point for cosine is 0, 1, which is a maximum. And my transform function point that I'm matching that up with is negative 5/8, which is a minimum. Because we're going max to min, I know that the A needs to be negative. Because the x-coordinate of my parent function is 0, the h is the x-coordinate for my transform function. And then to find k, notice that the y-coordinate on the parent function isn't 0. So I have to solve for this algebraically. So negative 6 times 1 plus k is equal to 8. So k needs to be 14. Is everybody okay there? Blake?
I'd just like a clarification.
Sure.
For sine graphs, when would A be negative? Like,
So
if it's from an x to a negative cosine, it would be negative. But then how would A be negative for sine?
So there's two different kinds of midline points for sine.
Okay.
So their midline point, one midline point has a minimum before it and a maximum after it. The other kind has max to min, right? Okay. So if they're opposite kinds of midline points, then the A would need to be negative.
Got it.
Okay. Now here, let's do the sine version. This is a little bit trickier because I can't use the point 0, 0 because that is a midline point. And I would have to send that to another midline point, but that's not what I have. I have a minimum. So I have to pick an extreme point from sine. So either pi over 2, 1, or 3 pi over 2 negative 1. It doesn't really matter which one you use. So I'm just going to use pi over 2, 1, which is a maximum. So again, that tells me that the A is negative. But to find my H and my K, I'm going to have to do this algebraically for each of these. So we have 5 over pi times pi over 2 plus H is equal to negative 5. So the pi's cancel, and I'm left with 5 over 2. If I subtract 5 over 2 from both sides, that gives me negative 15 over 2. And similarly for the H's, or I'm sorry, for the K's, is that okay there? Hi, Mr. Carl, come on in.
Thank you. Here you go.
Thanks.
None of the t-shirts are going to be the right size. They're just get the t-shirt that they get. And yours is red.
Oh, okay.
Because they didn't give us what we needed.
Oh, okay.
Okay, thanks.
Yeah, thanks. They'll be thrilled.
They will be thrilled. Some of them might work, some of them might not.
Okay. Is that okay with everybody, what we did there? Let's do another. So another kind of example. What if we did Hi, Mr. Sharp. Okay. So what if we're told that we have a minimum at -3, -10, and a maximum at 1122? And that's all we've given. Well, for something like this, I would probably start by just kind of sketching myself a picture to get an idea of what's going on. So like -3, -10 is down here, and like 1122 is up there. So since one is a max and the other is a min, it's going to kind of look like that, right? And I went and drew the rest of the period just with a dashed line. Everybody's okay? Obviously, this is not to scale, right? That makes a little bit more sense if I do that or something. So it doesn't look like the x-axis is right in the middle, because it's definitely not. Okay. Everybody's okay with the picture I've drawn, though? All right. Just like the previous problems, I'm going to start, or the graph problems, I'm going to start by finding the k. The k is halfway in between the max and the min. Everybody agree with that? So halfway in between -10 and +22 is going to be the same as finding the average between the two. So in this case, that's going to be 22 plus -10, or 6. Everybody's okay with that? Now, the A value, or the amplitude, I should say, is half the distance, half the vertical distance between those 2 points, right? So that would be y max minus y min divided by 2. Which is 16. Everybody's okay with that? Blake?
So when you're finding k, wouldn't it be y max minus y min?
No, because the k is in the middle of the two. It's like the midpoint.
Yeah, but then if you're going from 22 to -10, that would be a difference of, that would be a total span of 32, which half of that would be.
Half of it would be 16, so it should be 16 up from the minimum.
And then that's y equals 6. Okay. Perfect. Thank you.
You're welcome. Or 16 down from the maximum, right?
Yeah.
So again, I'd want to be adding to do it. Yep. You can think about it your way, but it's a little bit more like convoluted, which is fine.
I know,
Like as long as it makes sense, and the picture will make it make sense if you feel good about your picture and what you're actually finding.
Okay, thank you.
Okay, everybody happy there? So now I'm going to find the C. So I know from there to there. How much of a period does that appear to be based on the picture we've drawn? Looks like half, right? So to find that length for the half a period, I'm just going to take the x on the right and subtract the x on the left. So in this case, that is 11 minus -3, or 14. And then I know one period is 2 pi times the absolute value of c. So the absolute value of c is just 14 divided by pi. Or in our case, we're just going to use the positive c because we know there's an answer with a positive c, so let's just use it or find one of those answers. Is everybody okay with that? Yes, Dom?
So why would it not be 28 over 5?
So we have half of a period, and a period is that. So a half times 2 is 1.
Oh, okay.
And then I just divide the pi over. Cool? Okay. Okay. Now the last thing is to find the sign for A and the H. Is everybody still okay? All right. So which trig function would be easier to use here? Sine or cosine?
Cosine.
Cosine, because I have maxes and mins, right? So I'm going to use 0, 1. That's a maximum. And let's send it to 1122, maybe. That's also a maximum. It doesn't really matter which one you use. You could use the other one. It just, the values for A and H are going to change, but it's fine. Luke, go ahead. Yes, sir. So that tells me my A is positive 16, and my H is 11, and I'm done. That was pretty easy. If I had used sine, it's a little bit more tedious because, again, I have to use one of the extreme points from sine. Let's use pi over 2, 1. That's a maximum. So again, that tells me the A has to be positive, but to find my H, I have to solve this equation. So 14 over pi times pi over 2 plus H should give me 11. So 14 over pi times pi over 2 is 7. When I subtract that from both sides, I get H is equal to 4. Is everybody okay here? Again, if I'm bulldozing through something or you're not sure, stop me and ask, and we can re-explain some stuffs. Or if you're like, is doing this the same thing as what you're doing there, or anything like that, those are all fine questions to ask. They're all okay. We'll do one more example then, and then we'll be done. Sound good? Okay. Okay, let's say that here we're given that we have a midline point of 210, and the fourth extreme point after that is 10, 20. So I'm going to start by drawing a picture to kind of represent what's going on. So, I don't know, 210 is here. And then we have a fourth extreme point at 1020. I don't know, I mean, obviously I know that that extreme point is going to be a maximum, right? How can I tell that? I just look at the y-coordinate, right? 20 is bigger than 10, so that's got to be above it. Everybody's okay with that? So if I do max as my first, min as my second, max to be my third, that doesn't work. So I know it should be min, and then max, and then min, and then max. Everybody agree with that? Okay. So I know my midline point has to be right here. So that just has to be y equals 10. Because I know it has to pass through that midline point. So the y-coordinate from that midline point is just giving me my k right away for free. I don't have to do anything for that. Does that make sense to everybody? Okay. Next I'm going to do is I'm going to find my amplitude. So my amplitude is this distance. So that's going to be just y max minus k. So the amplitude is 10 also. Everybody's okay with that? Okay. Now I'm going to find my period, or my value for c by looking at my period. So this is 1 period, right? And then I have this much more is how much more of a period? It's like a half, right? So this is 1.5 periods. So I'll call that 3/2 periods is equal to the x on the right minus the x on the left. So 10 minus 2, which is 8. And a period is 2 pi times the absolute value of c. So the 2's cancel out. I'm left with 3 pi c. So when I divide both sides by 3 pi, there's my value for c. And as we've done so many times, we'll choose to use the positive value for c. Everybody happy so far? Okay. For this situation, should I use, what would be easier to use, sine or cosine? It doesn't matter because I have a midline point and I have an extreme point, right? So it's going to be an easy to find h either way. So it doesn't really matter here. So let's just do sine first. So from my parent function, we're using 0, 0, which was a midline point max. And we're sending this over to the midline point 210. And let's look at 210. So before 210 would have had to be a maximum. And then after 210 would have had to be a minimum. Everybody see that? So that tells me the a value must have been negative. And the h is going to be 2. So Blake, here's your example where sine has a negative a value. Or if I did cosine, from the parent function, I'm going to use the 0.01, which is a maximum. And from my transform function, I used 1020, which is also a maximum. So my a should be positive, and my h should be 10. Again, are there other answers other than these? Of course there are. Depending on which points you used to find your h and sine on A, you may get a different answer. But everybody's k, everybody's c, and everybody's absolute value of A should be the same. The sign of A may change depending on the points you used, and the value of H can change depending on the points you used. But here's the thing, even with the H's, they should be coterminal. So like if I used, like 3 pi over 2 or something, and you had negative, pi over 2, those are fine because they're it's still the same thing because they're coterminals. So, but there's infinitely many answers for all of these. We're just looking for one that works. Does that make sense? Now these, it's a little bit harder to get infinitely many of them because you just have one point to choose from. And like, why would you pick a point that you weren't given to use? Like, oh, I think that this point over here would have been yada, yada, yada. It's like, okay, well, sure, that might be right. But like, it's a pain in the butt to kind of figure that out. And like, why wouldn't you just use one of the ones that you're given? But I've seen all kinds of kids do all kinds of weird things. Typically on the test, I specify that you have to use one of the points that's given to find your, to find like your H and K. So just so I don't have to check like infinitely many possibilities, it's like, okay, it's going to be like one of these 8 things. I can write them all down easily versus like, oh, it could be one of infinitely many things. Now, if I get something weird, I have to like type it in the computer, make sure it like fits the same picture that I had before or whatever. It's just kind of a hassle. Anyways, let's stop here. Based on what we've done here today together, you guys should be able to do worksheets 2 and 3. So I would do worksheet 3 first. I think that going from graph to equation is a little bit easier because you have all the possible information provided, so you can kind of choose to do things kind of the easiest way. So there I'm asking on these problems to do both the sine and cosine answers. And then on worksheet 2, those are going from descriptions to equations. Here I don't specify the type of equation that I want, other than problem 3, which I specify I want the cosine answer. So on any other problem other than 3, you're free to write your answer in whatever form, sine or cosine, whatever is going to be easiest for you. Feel free to just do one of them. You don't have to do both. So that's that. And you should also be able to do from the problem set numbers 1 through 14, which are the same kind of sets of topics that we've just been talking about. Everybody cool with that idea? Okay. So let's talk about the asynchronous day and then what's due for homeworks. Sure. For your asynchronous day on Thursday, I've made a short video. It's about 15 minutes. All it is just me doing examples of these description problems that we've already done a bunch of examples for. You can choose to watch that or not. It's up to you. If you feel like you're good with what's going on, you can just skip the video. And then you should work on these worksheets 2 and 3. And then the homework or the problems 1 through 14. Everybody cool with that for the asynchronous day? Pretty light. It's basically just work on the stuff that we've been working on. Not much to do. For your homework checks, on Sunday, the 10th, all I need is worksheet 1. That's it. That's the only thing that we've had a chance to ask questions about before the Sunday, so that's all I'm going to ask to be due on Sunday. The following Sunday, the 17th, we've already now have on 1 through 14, worksheets 2 and 3, and we'll be adding some more stuff onto that next week. So that'll be a little bit of a bigger one, but get caught up on the worksheet 2 and 3 on this asynchronous day if you can, please. That would be a great thing to do. Maddie? So that's good